Is there any place in the world of FPV for a titanium frame? And the answer to that question is no, or maybe it's yes. Let's have a look at this frame and find out. And this is a frame here. It's cut completely from titanium. It's a 2.5-inch cinematic frame, and you can see it's got a central stack build there, so a central stack. And it's designed to take any sort of camera really, but it'll even take the DJI 03 cameras. So let's have a little bit of a look at it when it's completed. And this is the layout of the boards and everything, and the mounting of the camera. You can see it's actually got an underslung battery, which is interesting for a cinematic frame. But this is not the first time we've had a titanium frame in FPV. There's been one or two others, and they've had mixed reviews and limited success, I think, but they were freestyle frames. And I think they sort of fell down a little bit in their design and obviously their price as well. But the difference here is that this is a cinematic frame. Of course, it's still expensive. Any frame cut from titanium is going to be expensive. But in this frame, the titanium is used to give ultra thin and fine parts, not so much to give brute strength. If we have a look at the prop protectors here, the prop guards, you can see that they're incredibly thin. In fact, if we have a look at the thickness of the titanium, it's only 1.8 millimeters thick. And this is what interests me about this frame. I think having extremely thin prop protectors on this frame is going to give it a distinct advantage with this flight performance. To really understand this, we need to think about how prop guards or prop protectors were developed in the first place. You see, around about 5 years ago, in 2018, cinematic drones with shrouds became very popular. And the whole concept here was that the shrouds were going to give a tight tolerance between the prop tip and the shroud itself, and that was going to stop the tip vortices, and this would lead to greater efficiency. And this turned out not to be the case. I mean, the tolerances we could get between the blade tip and the shroud, this wasn't enough to decrease those vortices. And the more important point is that having that great big shroud, it just acted like a great big wind dam as you were flying through the air. And this really affected the performance of the quad. And this was the main point, and this was the main reason, I think, why we moved away from shrouds. And from there, manufacturers went away from shrouds and they went more to like prop protectors or prop guards, and they got thinner and thinner, and some of them even got holes in them. And this was to allow better airflow over the props and give less of that sort of wind dam effect that we had with the shrouds. And this would give a lot better flight performance. Now that's great, but of course with plastic there's a limit to how thin you can actually get before the plastic becomes brittle or just breaks easily. And that's where titanium comes into its own. Titanium can be very, very fine, very thin, yet still very strong. And that's what's drawn me to this frame. I think with this frame we're going to get very good airflow over the props. And another thing I like about this frame is actually the underslung battery. It reminds me of a frame, the Crux 35. That was a 3.5-inch freestyle frame, and I built that out and flew it. And I really liked the flight performance of having the underslung battery. So I'm going to be very interested to incorporate that, as well as these very thin prop guards on this, and see how it goes. But unfortunately there is a couple of caveats about this frame, a couple of things you'll need to know if you're thinking of building this frame out. By the way, you can buy this frame on my website. It's listed, but it's special order. You'll need to contact me. And the first thing is about the uprights. Let's take a look at these. So this frame is actually supplied with these titanium uprights. And the way that these are meant to be put in place is you put these little C-clips on, and they go below and above the frame. And to be honest, it just doesn't work. It wobbles and it moves. Now, of course, you can tighten this up by using your dampeners and squeezing them in tight, and building a very tight stacked frame. But to be honest, it doesn't really work, and I just went for M2 bolts instead. So fortunately, the holes on the bottom plate and the plate with the shrouds on it, these are actually M2 holes. But unfortunately, when you get to the top plate, if you look at the standoffs that come in the kit, they're actually M2 at the bottom, but they are something like M1.6 at the top. And so that means the holes in this top plate here are 1.6 millimeters. And you're going to have to drill them out. And this is a titanium frame, so you're going to be drilling titanium. It's not easy. What I found best was to use a little grinding tool like this and basically just grind the holes out in the top plate of the frame and just grind them out to 2 millimeters. So just remember, if you are going to build this frame, you also need to get yourself some either 30 or 35 millimeter M2 bolts. So from now we're going to build the frame out. I'll take you through the build process at different steps, different stages along the way, and then we'll do some test flights and see what sort of performance we can get out of it. Okay, so of course the first thing to go on is the flight controller. Now this one here is a GHF411. It's a JHE MCU brand and a 35 amp ESC. Okay, let's have a look at the mounting of the flight controller. So down here you can see I've got the nut just to keep the bolt steady. Above that I've got a little spacer here. It's a 1mm spacer, and then we've got the gommy, we've got the dampener. And I always like to use Loctite. Okay, this one here, the 243, and I'm just going to put a little bit of that on just above there. Okay, where the nut's going to tighten down. Okay, so I always tighten these nuts down, and just so there's just a little bit of pressure on the dampener. Okay, so this is the important part, so you don't get vibrations coming through the frame. Having that lock nut there secured with the Loctite, so it won't move and it won't tighten up or loosen onto that dampener there. And with the flight controller mounted, next is the motors. But first of all, you might notice these wiring looms here. I've got these running back over the flight controller. This is for the receiver and video transmitter. So I've actually done the dummy build to work out where I need to route these wires, and having them coming out here just doesn't work, so they're coming back over the board. For the motors, we're looking at 1404. I'm using these 1404 3800 kilovolt. To be honest, I'd really like to go with 4000 kilovolt or higher, but I've had these motors left over from another build and I don't want to waste them, so I'm going to go with these for a start. On this frame, the motor mount pattern is 9 millimeters and just 2 bolts to hold the motor on. It's quite adequate. The way I tighten up M2 bolts, I just tighten the bolt down until it stops, and then 2 more flicks of the wrist just to tighten it up. So I like to have the wires nice and loose on the flight controller, so they're not pulling too tightly on the flight controller. I'll probably strap them down to the frame here, so I just want to have them lying loose up here, and that's where we're going to cut them. So I'll just make a little mark there. Okay, just lay the wires back down again. Okay, just get them all in the right position, and that's all ready to be strapped down right here. Okay, so with the motors all soldered up, I've now attached one propeller here. So the next thing we need to do is we need to find out what height along this bolt here we need to mount the next part of the frame. So here's the prop protector part of the frame. Okay, so you can see with such a fine frame, we don't want to have it down too low or too high above the prop tips. So it has to line up exactly with the prop tips. So we need to find out exactly how much space we need to fill here to line that up. Now you can use the DJI-03 air unit, but I'm using a Vista here, and you'll notice I've drilled these holes out to 2 millimeters. So these are the 25 by 25 mounts. Normally they're 1.6 millimeters, and these are 20 by 20s in here. But I've actually drilled these out to 2 millimeters, and I'm using them to mount instead. So I'm going to use my own spacers on top of here, and I'll put a bit of 3 millimeter spacers down here as well. And with the prop guard plate in place, you can see I've conveniently routed these wires through the holes here, just to keep them nice and neat, and also to keep them out of the prop line. They actually feed inside here and up through the holes. For the Vista unit, I'm splitting the Vista unit. One of the boards is beneath the prop protector plate, and the other one's going to go above. With VTX mounted, this is a Vista unit here with one board below the prop guard plate and one board above. Next is the top plate, and I've just adapted this antenna mount here for the Vista unit so that it fits the holes here in the top plate. Okay, so here's the almost completed build. Let's take a little look around the frame, and you can see all the wires have been routed in through the frame here or through those holes there, just to keep them all neat and tidy and out of the prop line. I've got the receiver, ELRS receiver up the top here. This battery connector here, this is a 5-volt, just to power any sort of 4K camera, like a run cam thumb like that I put on top. Now actually this is probably best designed for a DJI 3 unit with the DJI 3 camera, but I don't have that, so I'm just using a Vista and a Cadex Polar camera here, and I'm going to put the run cam thumb up the top here. And to do that, I'll just cut a custom template from fiberboard to mount above the camera here and to hold the run cam thumb in place. Design similar to this I think should do quite well. And it's all finished and mounted. Run cam thumb goes in here like this. And we've got our power supply here as too. Okay. Might need a battery pad front of there too. Well, there we go. The only thing to do now is take it outside, chuck it in the air and see if it flies. Look at that. Doesn't that look nice? Okay, just down the beach here and testing the drone out. So it's a little bit of a windy day. Where you can see the ocean there. We've got a bit of buffeting and breeze, and if you look at the video now, by the way, this video is not stabilized, so we're just looking at the raw footage. So this is a video coming straight out of the run cam. It's the run cam thumb. So actually good conditions for testing this, because with a normal cinematic drone with, say, plastic shrouds or plastic prop protectors around it, I'd expect to get a little bit more buffeting than this. But even though I am getting a little bit of buffeting from the wind here, it seems to be quite stable. Okay, so a bit of a fly up the beach. Now, after this, I went to the park. I just want to try a little bit of, not really freestyle, but a little bit more aggressive sort of flying, and held up quite well there too. Right, and then down the local park for a little bit of cinematography, a little bit of nature here. So just flying around and having a look at some birds here. And actually, yeah, just very, very happy with the results. Once again, it's a little bit windy here. Yeah, looks nice. And that brings us back to the question of whether a titanium frame has any place in the world of FPV. And if we're talking about any other frame except for a cinematic frame, the answer is probably no. But for a cinematic frame, having these super thin prop protectors really makes a lot of sense. Now, this frame is completely made of titanium, which makes it ridiculously expensive. The top plate, the bottom plate, holding the motors, everything is titanium, even the camera mount. You probably don't need that. A carbon titanium blend would be suitable. Just the prop protectors made of titanium. So let's have a look at this one and we'll go over what I think about the build after flying it. Now you can see here a couple of changes I've made. I've gone with 5-blade props instead of 3-blade props. I just found that gave it a little bit more stability. And also I've got an antenna here for the ELRS as well, just for a little bit longer distance work. Another thing I've found is that this mount here, I actually made this mount myself, and to be honest, it's good, it works well, but it does wobble a bit. So an O3 air unit, which is actually what this is designed for, would make a lot more sense. Another thing about this build, you can see even here, like the camera wires come down here, and I wonder if I can show it to you. They come up here and they're funneled up through this hole here, along with other wires. So in such a tight build like this, where you've got this central column stack and the props in nice and close there, you really have to run all the wires. If we can have a look here at the front, you have to run all the wires up through these holes in the frame to keep them out of the prop line, and that's a little bit of a hassle and probably not the best. So there we go. If you do want to purchase one of these frames, I'll put a link down below. I've listed them on my website. Now, I'm not keeping them in stock. It's a special order, so if you want one, just contact me. And if you made it right to the end of the video, thanks for watching. Really appreciate it. Don't forget to like and subscribe. Let's have a look at some photos. Happy flying.